There we go. Sound check, 1, 2, 3, 4. There we go. Sound check, 1, 2, 3, 4. And we'll start in about 2 minutes. Thanks for signing in. right, it's a little bit past 4:30, so let's go ahead and get started. Chris, the DAG is just a shorthand for the Debian Administrator's Guide. There should be a link at the top of the Moodle site where you can get a download of it. I just decided to go that route instead of having you buy yet another book. So, just trying to save you a few bucks. Okay. Let's see, last week was discussion on FTP, and you should be doing the FTP quiz, or had finished it, and be prepared to do the lab this week. I will probably open that up as to extension until the end of next week, since I'm out of town. It's only fair. So if you have any issues with the FTP lab itself, we can handle it then. Okay. Now this week's, or leading into next week, this week's topic is HTTP. Okay. That's the piece we'd be working on, the quiz you would work on, that kind of thing. All right. HTTP is short for Hypertext Protocol, and its primary purpose was to provide a means of a client and a server to have a communications that was what they call connectionless. Okay? And by connectionless, you mean the following. Let's take FTP. If you start up an FTP session between your client and the server, you have a connection, a virtual connection over the internet between yourself and that FTP server until you log out. Okay? For HTTP, however, entirely different. You have your web browser up and you send a URL, like say www.amazon.com. It gets routed, okay, based on a translation in DNS, goes to the IP address of that server. The server responds and sends the text and the pictures and everything else back to your device. Once that's complete, there is no further communications. Okay? You have the whole page. It's in the memory of your PC or your laptop, and it stays there until you either close the browser or turn off your PC or whatever. The next communications is just another. Say you want to go to another page on Amazon. That's yet a new stream sent to the server for a request that gets replied back to. Okay? And that's yet another completion of the connection. After all the page information is received, the connection stops. Okay? That's why they call HTTP as a protocol a connectionless protocol. Okay? Now that causes a few problems, mostly on the programmer side. Okay? Most programmers are used to the idea of, I open up a session with between two devices and I have that session stream available to me until such time as one or the other of them time out or quit. Okay? So I don't have to have a lot of handshaking. It's all handled by the network. For HTTP, that's quite different. Okay? So let's say I want to buy something off of Amazon. Well, I might go through, 30 page views picking the items I want to buy. So how does Amazon track all that? Okay? And there's a couple ways they do it. The first one is there's a feature within HTTP, and most of the browsers that are provided these days, called cookies. And it's possible for the server to place a cookie on your client for information. Now these days with HTML5, they can literally plant 64 mega data if they wanted to in that cookie. Older browsers, it was more limited to like 5K or 64K. But with HTML5, it says they can do up to 64 mega data. I don't know of many that are doing it that way, but hey, that's what the spec says. So what they do, if I'm Amazon and you've properly logged in and identified yourself as who you are, they would immediately create a session key and send that to you as a cookie. Now one of the natures of a cookie is you can set it up so it has a certain time to live, just like a packet. Okay? And so you might set the session itself with a unique ID, and the cookie might only last an hour, 3,600 seconds. Okay. So I go through picking the things I want to buy. Each time I do another page, the client sends the session ID to the server, and the server says, oh, okay, I know this person, I know what they're doing, sends the next page. Okay. And if you pick another item, it gets in your basket. And they use the session ID on really both ends. You got it for here on the client, and you also have it on the server. The server sits there and says, oh, his basket's filling up with these items. I'll mark them each with a session ID to be sure I have that basket identified with the right person. You go to pay out, it's using your session ID again, plus whatever other information you've provided Amazon, and then bang, they place your order. Okay? And then at that point, once you're finished and you log out, eventually that cookie that was left in your client, it gets thrown away. Your browser will say, well, he's still browsing around looking at stuff, but it's on a different site and everything else. We're throwing the cookie away because it's aged out. Okay. Now, it's quite possible to set a cookie so it's unlimited time length, and that's how people that want to know what you're looking at, like say Google, actually do. They'll set a cookie on your browser, and they will literally set it unlimited and watch whatever you're doing session by session, what website you go to, what you're looking at, the whole 9 yards. But it's all done with session IDs and cookies. There is no standard for what a session ID has to be. That is up to each individual site owner to come up with whatever scheme they want. Okay. Some people actually use a little bit of JavaScript. They read the MAC address off of your client, and that's what they use for the session ID, which when you think about it, it does guarantee uniqueness in the network, because that's what a MAC address is supposed to be for. And it is probably one of the more popular ways to create a session ID, but it does require that JavaScript be turned on your browser, which you would have had to have done beforehand. Okay. So that's the whole idea of connectionless protocol for HTTP. Now, there's a series of verbs associated with the idea of HTTP. If you've ever looked at, the address bar of a site you've gone to, you might occasionally see an ID that says get or put or something like that. That's an actual verb used by the protocol to know what is going on. And the primary verbs that are being used, get is used primarily to retrieve a screen's worth of information from the server. Put is actually used to send information to the server. Delete, there is actual delete verb. You don't see it used too often, but the fact is you can send a delete command, and if the server is designed, or your application for that server is designed to recognize that verb, it'll actually operate on it. Get, put, delete. There's another one called push, which is pretty much like the put, only you're supposed to get validation of what you actually did. Okay? There's additional hand-holding and response back to the client as to how the transaction was completed. Okay. Now, HTTP also has a forms capability. Okay. And ironically, you would think in a standardized form, whenever you push submit on an HTTP form, the put action would be the one that's actually used to do that action. And indeed it is, but the odd thing is you can also use get to push a form to the server. Don't ask me why, it's just the nature of how the thing's set up. Okay. The preferred methodology is to do the push, or I should say the put, so that the server can actually recognize that verb and know it's specifically for receiving form information. Okay. And I wouldn't be surprised in some next iteration of HTML, HTTP, they get strict about that. They're somewhat stricter about it even with HTML5. So that looks probably as a going trend. So those are the verbs you get to use to have various actions. Now, most of those actions that you utilize are retrieved from the server for the next page view. Okay, so like you log in, let's say you're logging into your bank account. You go there and the first thing you see is the form for, logging in a password. All right, fine. That'll end up being a put, but the put was disseminated from the original get when you logged onto the site to begin with. So most all the actions that the browser implements all originate from the server, okay, in the classical way that HTTP is used. Now, I say that today, there is a trend in the development circles for the HTTP protocol and HTML itself. More and more of the workload of what would have been on the server, the update pages and that stuff, is now ending up on the client. Okay? I mentioned earlier you can store a 64 meg cookie. Well, not only can you store that cookie, but that cookie could include an entire SQL engine that's now stored in your client for the time of the session. So your own PC or laptop is now doing most of the work that used to be on the server. That's another outgrowth of HTML5. Okay? So the workload's now being split more and more between the client that does certain things and the server that does the rest. And a particular programming language that pushes this almost to the ultimate is something called Node.js. Okay? Look it up. You'll see that's one of the things they tout. They offload most of the heavy lifting of the protocol back to the client. Whether that's good or bad, I don't know. I guess it would depend upon your application. Okay? Now, what do we worry about ourselves as far as a networking perspective? Well, first of all, HTTP traditionally runs on port 80, okay, and HTTPS, which is the SSL encrypted HTTP protocol, runs on port 443 these days. Okay. So you got two ports potentially that HTTP runs on. If you were to roll the digital clock back to, say, 1990, port 81 was considered used for HTTPS, and then a standards change came across from ITEF that said, nope, 81 is going to be used for something else. So I doubt if you'll see it today. If you were to see some really old installation, you might see port 81 used. But the proper answers today would be port 80 and 443. Now, you could use any other port you want. Okay? I could set up an HTTP server excuse me, to work on port 8080. Okay, might be a test server or whatever, and I know that port number is not in use by any other application, so that's why I pick it. On my client side, how I identify myself to use the test server would be whatever the name or IP address of my server is, //8080, or in certain cases, the whole IP address :8080. Depends on what operating system you're dealing with. Okay. That additional information in the address bar of your web browser tells the web browser not to use the default port number, but to use this new port number. Okay. And it would go there instead. Use it for the information you want. In a lot of cases, most companies, they're usually figuring on a high port number for doing things like field testing, that kind of thing, testing new ideas that aren't going to go into production yet. And so you can have your production HTTP server run on port 80 and your test server run on port 9000, and you just have to redirect it to the right port. So that's easy to do. What else? As far as network load, as HTTP, the protocol itself is very lightweight. That was one of the reasons it's been in use. Where the heavy load comes from is the imaging these days that get utilized as part of the protocol. So, you know, the web page itself might paint in a matter of half a second, and then all of a sudden you see this slow progression of the images come across because they are, you know, there's an image. I mean, I might have a 2 meg image to come across, yet the web page itself is only 50K. So you see that quite often. Let's see, port number, services. That covers the networking side of it. Now the application side. Okay. As far as Linux or Unix is concerned, there are a whole series of HTTP servers I can pick from. I can pick the default. The big kahuna out there is still Apache. Okay. In fact, right now it's Apache 2. So if you're actually going to go look in the repositories to install HTTP, you'll see that this actually gets listed as typically HTTP 2 in a lot of cases, with all the components that go with it. Apache's not the only one out there. There's Lightspeed, AOL. Yes, AOL still has a web server out there. Microsoft has their own web server image. Now, unfortunately, we don't have an open source version of their product, so it wouldn't be in our repositories, but Microsoft does build one. There's some of the others. I think that covers most of it. There's about, if you were just go in and do an Apache or aptitude search HTTP, you'll probably see six or 8 hits for different web servers. And they all have pluses and minuses. Okay? Apache is the big one because it has all the bells and whistles, and if Apache 2 can't do what you want it to do, probably none of the others do either. Okay, so that's why it's generally most popular. There are some web server engines. There's one called Cherokee. It's very lightweight as far as using resources on the server, but it's a trimmed down thing. You can't do everything that Apache can do. Okay, so you pay lack of convenience by using a lightweight one like Cherokee versus a full-throated one like Apache that has everything you could possibly do with it. Okay. As far as installing Apache itself, again, using either apt-get or aptitude, you can, once you've found the one you want, you can just load Apache 2 into the system. So use whatever the naming nomenclature that's in the repository for that package. And I would suggest you install that one because some of the questions you might see on a midterm or final will refer to it. Now, Apache is a brand of HTTP server called a caching server. In other words, it can store in memory the more popular pages if you want to set it up that way and have the memory space to do it. So like your front matter page is the very first start page for your web page. You might want to have that cached in memory so there's a faster response. Your choice as the operator. Apache also takes a view that I can do virtual hosting. Okay? And by that, what it means is you have one instance of software running, so there's only one copy in memory, and that one copy in memory can be utilized to host, say, 6, 20, or 200 websites. Okay? And how you manage that is called a virtualization process. At least that's what they call it, okay, virtual hosting. And what you are required to do, and you'll actually see it, go into the SE subdirectory, look for Apache 2. There will be a subdirectory by that name. It's either that or HTTPD, one or the other. Okay. Go into that subdirectory, and you'll notice there's a whole series of another set of subdirectories. And some of them say site available, okay, and there's really two primary subdirectories, the site available and the site enabled. Okay. The site available is just a configuration of a virtual site, but it's not turned on. Make a copy of the contents of that site available subdirectory into a equally named subdirectory in the sites enabled, and now that turns that virtual application, that virtual website on. Okay. And that's how Apache manages virtualizing multiple websites on a single clump of software. That's how they manage it. Want to turn that site off, all you got to do is just delete the subdirectory that references that particular site. Bang, it's down. Okay, so that's how they handle it. So take a look in the SC subdirectory and you'll see what I'm talking about. And there is a default subdirectory called default, and I think it starts out with 000-default. That is the primary subdirectory if you don't do any sort of virtual hosting. Okay? So it's always there. In fact, when you go to do the lab, what you'll want to do is install the software just straight out of the box. Don't change anything. The default will already be turned on for you. And point your web browser, just launch it and type in http://127.0.0.1. Okay, that's localhost. It will go to the default site, and you should see a web page displayed that says it's running and has a little feather, Apache 2, and a little greeting. So that will actually tell you that your website is actually running. Okay. Now, yes, you could change the contents for the default site if that's the only website you want to run, and use that all the time. You don't have to use virtual hosting, okay, but a lot of people do. Okay. It is possible with a configuration change to direct Apache to what is called the root of the website. In other words, within a directory tree, the top level of the directory as far as the website is concerned. Okay? And so by making a simple directory change in the configuration file, I can actually say, well, no, the website used to be at /var/www/default. I now want it to go to /var/www/new development. And then at that point, the web server will point to the new directory tree instead of the old one. Okay? And that's done quite often. In a lot of cases, companies will run the platform on the current directory tree for what their production is, and the test one on another directory tree. And when they think they got their test facility production ready, all they do is they go into the configuration file, change the directory reference, and boom, now the new site's running. So there's a lot of companies that do that as well. There are some companies that actually use the virtual hosting to actually do their development, and then they make the necessary changes in the configuration file later to point to that particular virtual hosting location as their new production site. Either way works. Okay. Some of the other things you can change to enhance Apache 2, since that's the package you're using, you can set the timeout level. Okay, because what Apache does, for all the connections that it has previously had, it maintains that information in a table so it can increase its response time. And you can set the time interval, I think its standard is like 300 seconds. You can change that interval shorter or longer. If you want to increase your response time, make it longer. That way the information in the table is retained longer. Or if you need to have a fast refresh, make the time shorter, and then that information in the table drops off earlier, which speeds up the server software somewhat. Okay. Modules. Just like Linux itself, the Apache 2 is a modular system, and you can install different subunits of software for Apache to utilize to recognize things. I mean, they got submodules that you can load into Apache so it'll recognize ASP code. It's not part of the default config, but the fact is you can do it. You can put in modules for it to recognize Python code, that kind of thing, and act on it. So there's a whole series of module options you can utilize if you want. The default ones that are set are strictly HTML code and what's called CGI, Common Gateway Interface. And those are the two primaries that are typically set on default for Apache. Okay. Dependencies, which is one of the things that you have to do as part of the quiz. I would just simply suggest run the Apache or the apt-cache space depends and the package name, and it'll give you a listing of the dependencies. There are quite a few for HTTP, again, because it's a modular design. So the list is going to be a little bit long, but I mean, that's okay. Other than that, I think that's most of the highlights for HTTP. Like I say, when you go and do the install for the lab, I think you'll find it's fairly straightforward for something right out of the box, and you should probably on the first try be able to get a local host connection right onto the system. Okay. Should be able to do that with just no problem at all. If you can't, you might want to check your host file and see if there's something else taking that port stream of 127.0.0.1. It might be taking it before HTTP sees it. That could be the only thing I can think of that would cause a problem for the lab. The last thing is, and I'm not trying to turn you on to programmers, and I'll probably cover it next week, is the HTML coding itself. I'll go over a little highlight of that and just show you, primary structure and that kind of thing, so you know what's there. And we'll go over that next week. So, and that basically should do it for the prep for the lab and quiz. Okay. There is a section in the DAG manual that covers actually issues with Apache 2. You might want to take a look there as well for reading some reference material. And other than that, that should pretty much cover it. Okay. All right, at this point, I'll open up the floor to any questions. Just shoot the question into the chat, and I'll wait here a minute or two. And then after that, we'll call it a day. And you all have a great weekend, and I'll see you next week. I see, Chris, you did find the link for the DAG. That's good. All right. At this point, I'll call it a day. And all right, hold on a second, Chris. Let's see here. Then you don't see the one that says, well, maybe that's grayed out. Turn it, hold on a second. Check something. Take a look now, Chris, see if you can see it. Good. All right. Okay. Well, that'll do it. See you next week, and have a great weekend, all. Appreciate you all coming on board, and I appreciate your indulgence on me being able to handle some personal matters and doing this long distance online. Thanks a lot.